Hello, my name is Scott Mesjian, and today I'll be walking through problem 70 for our week 5 for these explainer videos. Two identical loudspeakers separated by distance delta x each emit sound waves of wavelength lambda and amplitude a along the x-axis. What is the minimum value of the ratio for delta x to lambda for which the amplitude of their superposition is also a? This problem's really wordy, but basically what it means is that we want a graph that when we combine two, the amplitude never goes over A. So how can we do that? Just a quick reminder on what superposition is from the chapter. It's basically when you add two waves and then you just add up their amplitudes at every point. So for example, if I had a wave like here, um, basically I'd add these 2 points up together. So this is a little less than A. So then that answer would, the superposition would look something like this at that point. But yeah. Anyways, the wave formula for this chapter looks something like d of xt is equal to a sine and then a bunch of stuff, right? What we really care about for this problem is just the a, sine, and whatever. So yeah, now we want to think about how we can make two of these a sine functions. We'll just say this is x. A sine of x, how can we make those two waves add up to a? And so the way we would do that is just by setting a sine of x equal to half of a, right? Because then if we have two, half of a, we get a. So let's do that. So we have a sine of x is equal to half of a. And with that, we could just cancel out the a and solve for this. And if you plug this in your calculator, you might get two answers. That will give you what is pi over 6 and 5 pi over 6. And if you look at the graph, this makes sense because this value right here would be pi over 6, and this value right here would be 5 pi over 6. So now we have those. That's great. So now we know that this point on the graph and this point on the graph, if you added them up, you'd get A. So now we're thinking, okay, how can we make two graphs start so that their superposition adds up to A? Well, what if we just started the graph by this 5 pi over 6 minus pi over 6 so that we could start the graph so that it would essentially be delayed by that amount. So what is that amount? It'd be 4 pi over 6, or that's also written as 2 pi over 3. So now we know that the second graph should be delayed by 2 pi over 3 to get two waves that add up to A. So that would look like kind of like this. And so they'd add up to A, and then they'd add up to A right there, or negative A, and then add up to A right there, and so on. So yeah, let's think about the other part of the problem, because we want to see the ratio between delta x and lambda. Well, in sine of x, the lambda, or the wavelength, is 2 pi, because you go around a whole circle of sine in 2 pi. Like this would be pi, this would be pi over 2, yeah, etc. So this would be 2 pi. So then if we just plug in what we have for our delta x, which is 2 pi over 3, and for our lambda, which is 2 pi, we just get 1/3. And if you want to write that in ratio form, that'd just be 1 to 3. Also, a bit of context. This is similar to how if you added the waves at pi apart, you'd get a standing wave. Or sorry, not a standing wave, but just a flat line. And then if you added them at the same point, you'd just get 2a, kind of like that. Yeah. Thank you for listening. If you have any questions, please let me know.